Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we'll discuss about question number 43, NEET Physics paper 2016. Students, let us solve question number 43. A uniform rope of length L and mass M1 hangs vertically from a rigid support. This is the rigid support. A rope is hanging like this. The length of this rope is L and mass M1, a rope of length L and mass M1 hangs vertically. So this mass is also M1. A block of mass M2 is attached to the free end of the rope. So there is a block here which is attached to this free end and its mass is M2. A transverse pulse of wavelength lambda 1 is produced at the lower end. At the lower end here, a transverse wave pulse is produced. This is the wave pulse which is produced at the lower end, and it has certainly has to travel along the length. The wavelength of the pulse when it reaches the top. So when it reaches here, suppose this is the wavelength, whatever is the wavelength here, that is suppose L2. When it is here, the wavelength is L lambda 1. The wavelength of the pulse when it reaches the top is lambda 2. So here the wavelength is lambda 2. Your aim is to find the ratio of lambda 1 over lambda 2. Now, when a pulse is created here and I give a certain jerk, a pulse is created and that travels upward, and then if travels upward, then the wavelength will be different. That way to see. This is having mass M1. This is not a massless. This is not a massless rope. It is having certain mass M. M1. This is having mass M2. So we know that for any wave pulse or any wave that is produced, the velocity of the wave is frequency into wavelength. This is for all types of waves. This formula can be used. So for this wave pulse that is generated, I write that velocity is frequency into wavelength. Now, because this is universal formula and because the pulse that is generated in the string is transverse in nature, so the velocity of transverse wave is equal to T divided by mu under root. What is this T? T is the tension in the string. Corresponding to that we get the velocity. So I can relate these two equations, that frequency into wavelength equals to T by mu under root. So from here I write the lambda is proportional to under root of T, because I have to keep one variable and other two constants. So if I see that my wavelength is changing, then the speed is frequency to wavelength. So if this is changing, then someone else will change, but the other one will remain constant. That we can keep that speed constant, the both will change. So this relation I have to use actually. So the ratio of the wavelengths will be proportional to the ratio of the tension at these 2 points. At this point, and at this point. At this point and at this point of the rope, this point is having a tension, and here the tension is due to the whole mass suspended here, that here the tension will be, suppose that is I call this tension as how much is the tension? Tension is the mass lying below this point is the mass of this length and the mass of this block m1 plus m2 into g is the tension here. What will the tension here? Tension here will be only the mass that is lying below this, that is the tension is only m2g. So the wavelength ratio is proportional to the tension ratio. The tension here it is m2 and here the tension is this one. So the question is to find lambda 1 over lambda 2. It comes out to be something like that. So the tension at the lowest point to that of highest point is given by, because it's proportional to that, so it is T1 over T2 the root. Okay, so T1 is the tension at the lowest point and it is the tension at the highest point. Now if you see that this is lambda 1 over lambda 2 and lambda 1 over lambda 2 equals to T1 over T2. T1 is the tension here, which is m2g. T1 is m2g, so I'll put m2g, and T2 tension here, T2 is this one, m1 plus m2 into g. Root, this will cancel, so lambda 1 over lambda 2 equals to m2 divided by m1 plus m2 the root. This is the answer to this question, but here there is no options, so you have to change the ratio of this. Actually there is a misprint here. It is not lambda 1 over lambda 2, it is actually lambda 2 over lambda 1, so that will ratio will change. So lambda 2 over lambda 1 will be m1 plus m2 divided by m2 under root. m1 plus m2 divided by m2 under root, so option number 3 is correct. Okay, this is option number 3. This is the right answer to this question. Thank you.